clusters of over-predictions in red and under-predictions in blue. This clustering happens because we're trying to understand relationships that vary across space. And ordinary least squares does not take these complex spatial relationships into consideration. In order to take into account the complex spatial variations in our data, we're going to use geographically weighted regression. Running our analysis, again using those same variables, we can see that our R squared is now up to 85%, a much better prediction model than using ordinary least squares. Now, when we look at our over and under prediction, we can see that there's much less spatial clustering. But why are our results so much better using geographically weighted regression? The complex spatial relationships in geographic data play a very important role in our analysis. Here we're looking at the relationship between one of our variables, distance from mass transit, and growth. This map shows us that home buyers don't want to live too close to the metro, but they also don't want to live too far away. That same variable has a very different relationship with growth depending on the geography. We can trust our prediction model because we've taken into account these complex spatial structures, whereas ordinary least squares assumes the same relationship across our entire study area. Now that we've found a model that we can trust, we can actually predict where growth is going to happen in the future, which has major implications for managing resources and decision making. One county that's predicted to experience especially high rates of growth is Loudoun County, highlighted here. To deal with growth, there are plans to construct new schools and extend the existing mass transit system. Using geographically weighted regression, we can take our predictive analysis one step further. We can actually analyze the impact of an infrastructure design decision, such as extending the mass transit system. We already know that distance from mass transit is a variable that helps us predict growth. Now we can rerun our analysis to include the proposed changes to that mass transit system. Here we're looking at the impact of the proposed metro. The areas in yellow are predicted to experience increased rates of growth. Using our analysis, we're now able to discover impacted areas that might have otherwise been overlooked. Now we're aware of an area of the county that may need to be reevaluated so that adequate school capacity exists. We hope that this demonstration has shown you how our advances in spatial statistics in ArcGIS 9.3 can help you understand and predict complex spatial phenomena and make better decisions.